Okay, on this example, we're trying to find the area between two given curves on a specified interval. So from -1.5 to +1.5 for x values. And then we're going to round our solution to two decimal places. So our two functions are y equals -x to the fourth plus 4x squared plus 4, which is going to be this curve going across here. And then this linear curve, so a line, y equals x minus 1. Slope of 1, y-intercept at -1. So it's this bottom curve here. All right, so to set this up, we want to set up our bounds of integration. So that was from -1.5 to +1.5. We didn't have to do any work to find those. Those were given in this problem. And next, we want to have it set up so that you take the higher function, the upper function, and subtract away the lower function. So the upper function is that -x to the fourth plus 4x squared plus 4. And we're going to subtract away x minus 1. And we put a dx at the end because we have x values going on here. All right, from this point, what we want to do is just do a little bit of simplifying. What I would do is I would think about distributing this negative to both these terms, get rid of that set of parentheses, and it'll look a little bit nicer. So we're looking at the integral from -1.5 to +1.5, -x to the fourth, plus 4x squared, and then we'll have a minus x to the first power as we distribute that negative, and then we'll have 4 plus 1 will make a +5. The 4 plus 1, we had +4, and then you distribute this negative to this -1, that'll make a +1, 4 plus 1 giving us 5. All right, next up, let's actually do the antiderivatives. All right, so as we take the antiderivative here, we're going to bring along the negative, we'll increase the exponent by 1 and go 1 over the new exponent, just our power rule. Plus, the 4 can come along, we increase the exponent from 2 to 3, and then we divide by our new exponent. Minus, again, increase the exponent that was 1 up to 2, go 1 over that new exponent out in front, and finally we have 5x. You just put an x with it because the derivative of 5x is 5. Now all of this needs to be evaluated still from -1.5 to +1.5. So we'll bring along those bounds of integration. All right, to finish this up, all we need to do is we're going to plug in our upper bound for each one of these x's the whole way through, and then subtract away when we plug in our lower bound. So let's take our time and do that. That's going to be -1/5. 1.5 gets plugged into the fifth power, plus 4/3, 1.5 to the third power minus 1/2, 1.5 to the second power, plus 5 times 1.5. Doing this kind of quickly, but I don't think it'll be too big of a deal. All right, and then subtract away. I'm using a big bracket here as we plug in our -1.5 for each one of the x's. Minus 1/2 times -1.5 squared plus 5 times -1.5. And we'll close that off. At this point, because we're trying to round to two decimal places, I'll probably get my calculator out instead of doing intermediate steps. I'd probably just get it all into my calculator at the same time. This will work out to be approximately 20.9625. But as we're rounding to two decimal places, we'll just use 20.96. All right, I hope this helps out in setting this up and solving down. It is always nice when you have a picture given to you where you can see both these graphs on the same plane. In the case that you can pick out that this is not the linear function that's going to be on top, and then our linear function is definitely below. That's why we went with the x to the fourth function minus the linear function on the setup on the inside here. All right, good luck on these. I know that they can be challenging, but work on the setup. You can get through them. Good luck.